Hi and welcome to this session. In this session, we are going to discuss about determination of calorific value by Boyle's gas calorimeter from unit 4, that is fuel. Learning outcomes from this session will be: students should know the use of Boyle's gas calorimeter. Students should understand principal, components and working of Boyle's gas calorimeter. Students should be able to select the calorimeter to determine the calorific value based on state of fuel. Now, Boyle's gas calorimeter is the calorimeter which is mainly used to determine calorific value of a gaseous or highly volatile liquid fuel. The principle of Boyle's gas calorimeter is: a gaseous or volatile liquid fuel is combusted at a known and constant rate. The heat produced by combustion of the fuel is completely absorbed by the water flowing through the calorimeter. By knowing the volume of gas burnt in time t, the mass of water collected in time t, and rise in temperature of the water, the calorific value of a gaseous or volatile liquid fuel can be calculated. So this is the diagram of Boyle's gas calorimeter, and we will discuss the components of Boyle's gas calorimeter. So the components are enlisted as: first, gas burner assembly; second, combustion chamber or calorimeter; third, insulating cover; fourth, thermometer. Now we will discuss the components of Boyle's gas calorimeter independently. First component is the gas burner assembly. So the gas burner assembly in Boyle's gas calorimeter is a flat flame gas burner assembly. The gas burner assembly is provided with a pressure regulator, pressure meter, which will help to monitor the flow rate of gas and ultimately combustion rate of the gas. This assembly, that is the gas burner assembly, is situated at the center of copper calorimeter or combustion chamber. This is the diagram of a copper calorimeter or combustion chamber. The copper calorimeter will absorb the heat produced by combustion of a gaseous or volatile liquid fuel with the help of a copper coiling provided with this copper calorimeter. So this copper calorimeter or combustion chamber is provided with copper coiling. So this is what the outer coil present with the combustion chamber, and another coiling is the inner coiling. So these are the inner coils provided with the combustion chamber. Now this outer coil is connected to the inlet of water, so that water will enter through this inlet. It will flow through the copper coiling, outer copper coiling, towards downward of this combustion chamber. So water will enter here, it will travel through this copper coiling towards the downward, and from downward it will enter into the inner coiling. So it will enter into the inner coiling and it will flow upwards through the inner coiling. Now this inner coiling is also provided with the outlet. So through the inner coiling, water will travel towards upward, and through this inner coil which is connected to the outlet, the water will be given out. During this process of flowing of this water, the water will absorb the heat produced by the gas burner assembly due to combustion of a gaseous or volatile liquid fuel. So this is the construction of the copper calorimeter or combustion chamber. The combustion chamber or copper calorimeter is further surrounded by the insulating cover, which will avoid the loss of heat due to the radiation. The insulating cover is also provided with exhaust, which will be used to eliminate the gaseous products produced during the combustion of the fuel. The outlet from the copper coiling is further given out in a container which will collect the water from the outlet. So the water will be collected here and it will be measured in order to calculate the GCV of given fuel. The insulating chamber is also provided with another outlet at the bottom. This outlet will be used to collect the condensed steam which is produced during the combustion of the fuel. So during the combustion of the fuel, hydrogen from the fuel will get converted into water molecule. This water molecule produced during the combustion will be condensed and it will be collected in this container at the bottom of this insulating chamber, which will be further used to calculate the LCV of given fuel. The next component of the calorimeter, Boyle's gas calorimeter, is the thermometer. First is the thermometer T1, which is placed at the inlet of water, which will measure the temperature of incoming water, while second thermometer is the thermometer T2, which is placed at the outlet of water, which will measure the temperature of outgoing water. So by knowing the difference between the temperature given by this thermometer T1 and thermometer T2, we will be able to find out a rise in temperature of water. Now we will see the working of Boyle's gas calorimeter. First, allow the gaseous fuel to flow through the gas burner assembly. After that, ignite the fuel and by using the pressure meter provided with the gas burner assembly, adjust the combustion rate of gaseous fuel. Further, allow the water to enter into the system. So here from inlet the water will enter. This will flow from the inlet towards the outer coil. Now from outer coil the water will flow towards the downward through the outer coil. So here the water will flow from this outer coiling towards downward. From bottom of the combustion chamber it will enter into the inner coil, and through this inner coil it will travel upward. So through this inner coil it will travel upward, and from here it will be given out. So at this junction this will be given out through the system. Now during this traveling of this water, the heat produced by the combustion of the fuel will be absorbed by this water, and that leads to the rise in temperature of water. Further, in the next step we have to maintain the flow rate of water constant so as the rise in temperature in thermometer T2 will be constant. As soon as the temperature of the thermometer T2 will be constant, then allow the assembly to get stabilized for few minutes. After few minutes, we have to note down following readings. So from the above experiment, we have first volume of gas burnt in time t at STP, that will be equals to V liter. Generally, the flow rate of gaseous fuel or the volatile liquid fuel is maintained around 3 to 4 liter per minute. Then mass of water passed through the copper coil in time t, that will be equal to W kg. Then mass of water produced during the combustion of fuel in time t, that will be equal to m kg. Now this m kg is the water produced due to combustion of the fuel, which is collected at the bottom of the insulating cover. Now this is the amount of water produced by combustion of V liters of the fuel. So for 1 liter of the fuel, the mass of water produced will be equal to m upon V kg per liter. Then temperature of incoming water, which will be measured from thermometer T1, that will be equal to T1 degree Celsius. Temperature of outgoing water, which will be measured from thermometer T2, that will be T2 degree Celsius. Let L be the GCV of the fuel. So L be the GCV of a fuel, that means it is the amount of heat liberated by complete combustion of unit mass of fuel. As we know that amount of heat produced by combustion of the fuel is equal to amount of heat absorbed by cooling water. As we know that amount of heat produced by combustion of the fuel is equal to L into V. So L into V will be equal to capital W into T2 minus T1. Here capital W is the mass of water passed through the copper coiling in time t. So GCV of given fuel, that is equal to L, which will be equal to capital W into T2 minus T1 divided by V kilocalorie per meter cube. Now we know that small m is the mass of water produced by combustion of V liter of fuel. Hence the mass of water produced by combustion of unit volume of fuel will be equal to m upon V kg. If 587 kilocalorie per meter cube is the latent heat, then latent heat for m upon V kg of water will be equal to m upon V into 587 kilocalorie per meter cube, as LCV of fuel is equal to GCV minus latent heat of water. Hence LCV will be equal to capital W into T2 minus T1 divided by V minus m upon V into 587 kilocalorie per meter cube. So these are the formulas to calculate GCV and LCV by using Boyle's gas calorimeter. So in summary, we have discussed about Boyle's gas calorimeter and its use, principle of Boyle's gas calorimeter, components of Boyle's gas calorimeter, working, formula to calculate GCV, formula to calculate NCV. So thank you for attending this session.